honors algebra students, Mr. Lawrence here, and this should be a really quick video. We're just going to be talking about domain and range, and you got pretty good at this a while back, so it's just kind of a refresher, only it's not really review, but it's applied directly to quadratic equations. So I've got two quadratic equations here graphed already, one in red and one in blue using my old friend Desmos.com. We're going to talk about the red one first. All right, remember, domain is the input, the set of all possible x values, and range is the output, right? Set of all possible y values. So as I look at these parabolas, I'm only going to look at the red one right now. Excuse me. To find the domain of it, I want to know what is x allowed to be. I mean, like, can x be 0? Well, sure, if I go to where x is 0, and then draw a vertical line, I hit, right, a y value right there. Oops, I'm on the wrong graph there, sorry. Am I on the right graph now? Yeah, there we go. 0, -4, that looks right. Okay, if I go to where x is 1, which I think would be maybe here, then I get a y, the corresponding y value is 3, right? Okay, so what x values can there be? Well, if you take a vertical line and move along here, I think you're going to find that there is no restriction on any x value at all. I mean, look, we're at 200, and yeah, the parabola's not touching it yet, but if I go up far enough, it sure will. Let's see what the coordinates are here. Look at that, 26 and then 674. So it's climbing very rapidly. It's not very wide, but the domain is definitely going to be all real numbers. If I put a fraction in front of here, say like a 1/4, now my parabola widens out. Maybe it's easier for you to see in this way that the parabola is just going to keep getting wider and wider and wider, and therefore going to hit larger and larger and larger numbers. Okay, if I put like a 1/100th in front, well, now this thing's really wide, and it's obvious to see that 200 is hitting a value there. Right, let's see, 200 is at 396, right? Okay, so the domain is all real numbers. What's the range? Well, the range is the set of all y values. For that, I want to use a horizontal line, right? And it looks like this parabola goes into the large positives, 10,000, 10 million, 100 billion. It has 0, it has some negatives, but not all negatives. It looks like the vertex is at 0, -4, right there. Are there any y values that are less than -4? Let's see. No, there aren't. See that? The y values are getting larger and larger and larger, eventually getting into the positives, right? So I go negative, 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 getting smaller, 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 hit the vertex. -4, and then when they get onto this side, sorry, I got two vertices showing there, wrong one. Over here, then they just start to climb again. So my range is going to be all real numbers such that y is greater than or equal to -4. So let's write these out here. This is problem number 1, the domain. Okay, you can do all real numbers. Ooh, not all real pie. Sorry, I must be hungry thinking about pie, Dutch apple pie with a slice of ice cream. No, just kidding. Do all real numbers. Okay. And then for the range, you can say all real numbers such that y is greater than or equal to -4. Or you could do it using interval notation, right? The domain would be -infinity to +infinity. The range, that's the domain, the range would be from -4 toward infinity, right? Remember that? Or set builder notation. Okay, in set builder notation, the domain would just be all real numbers x. Just like that. You wouldn't put any restriction on it. The range would be all real numbers y such that y is greater than or equal to -4, right? Just a little bit of review. Okay, now let's take a look at the other one. Let me get rid of some of this, and we'll do the same thing for number 2. Okay, number 2. Dun, dun, dun. All right, number 2 with the blue one. It looks like, once again, that x can be any real number. Yeah. Y looks like it can be anything below whatever the vertex is. Well, if you want to do negative b, so it'll be negative 8 over 2a. So let's go do that. So the x-coordinate of the vertex is going to be negative b over 2a, and I think that's at negative 2. Yes, so let's go back and double check. Boom. That's correct. Negative 2, 8, and negative 5. So it's y equals negative 2x squared plus 8x minus 5. All right, so when I do this, I'm going to get negative 8 over negative 4. So the x-coordinate is 2. That's the x-coordinate of the vertex. I need the y-coordinate of the vertex. So to get that, I'm going to do negative 2 squared plus 8 times 2 minus 5. Well, that's going to be 4, negative 8. That's going to be positive 16. There it is again. That middle one is double the other one. Minus 5, and I think y is going to end up equaling 3. Okay, so this vertex here, this vertex is at the point 2, 3. And look, it's showing up pretty right now, isn't it? Oh, no, it's not. Very strange. Oh, there it goes. All right, 2, 3. So the domain is all real numbers, and the range is all real numbers such that y is less than or equal to 3. So we'll write that out. I won't write it in all the different forms today. For this example, you can handle it. Domain is all real numbers x. I'll do set builder notation. And the range is all real numbers y, such that y is less than or equal to 3. All right, that's it for the video. Like I said, it's kind of a review video. It's just applying it to quadratics. All right, Mr. Lawrence signing off. Have a good night, everybody.